Yeah, so the first problem of this contest, short sort, it said that there are three cards, A, B, and C, and like the cards have this A, B, and C written on them, and we have to like we can apply this operation at most once. The operation is just to swap any two cards, and we have been asked if it is possible that we can have A, B, C in a row after like exactly one operation or like at most one operation. So the problem is something like this. We have been given three cards A, B, and C. They can be in any order. So there are at most three, like six orders possible. A, B, C, C, B, B, A, C, B, C, A, C, A, B, and C, B. Like these are the only six possible orders of the three letters. And we have like we can uh, make this operation at most once, in which we just make swap two elements, swap any two elements, any two parts. So you can just manually check that, hey, this one is already correct. You can swap these to get it correct. For this guy, you can just swap these two. For this guy, you cannot make any swaps. You can try, but I think there are no possible swaps here. And this one also cannot be swapped. And here you can swap these two, so it will also be. So if the string is any of these three or this one, then the output is yes. And for this one, the output is no. This is one of the ways of solving this problem. The other one is just like you want it to be ABC. So just check how many problems are there. Like here B is not equal to A is not equal to B. So you got two problems. Here in this case, you don't have any problems. Here in this case, you see that this is a wrong card, this is a wrong card, like card at incorrect position. So the problems are two. And you can just count the number of cards which are at uh, incorrect places. And if the number of cards at the wrong places is three, in that case, you will just print no, else you will print yes. So does it make sense to you guys? Just write yes or no inside the chat. That does it make sense? Obviously, I didn't discuss it too into depth because this is something very obvious. I guess it's quite obvious. And in case if somebody feels that it's not obvious, then it means you need to spend more time to think about it. Let's move on to the code for this problem and let's move on to harder problems. Just covering up the easy problems first. Here I just took the input string and then declared a variable def. This is something like defect, short form of defect. And then I said k if A is not present at the first place, B is not present at second, C is not present at third, and those places just increment the count of defect. And if the count of defect is greater than 2, which means it is 3, then in that case print no, otherwise print yes. And the problem got accepted. The code got accepted. So let's move on to the next problem. The problem is good name, sorry, good kit. It says that um, in simple words, like I'm just going to tell about the problem with you. It says that you are being given an array. It can have values like A0, A1, A2, A3, and so on. And you can make one operation. In one operation, you can just choose any AI and make it equal to AI plus 1, like just increment it by 1. And you want to find what is the maximum possible, like for the next array. Let's say, like once you make the changes, then the resulting array A0 into A1 into A2 and so on till AN minus 1 should be maximized. You want to like you want to find the maximum possible value of this. So here we just had to make a small, like, very small observation that let's say you say AI like A1 is equal to A1 plus 1. You incremented the value of A1. So if prod this was the initial product of the array, then in that case, and sum was the initial sum of the array, then in that case, sum minus A1 and like prod plus this. This will be the new product. you just had to realize this, that this will be the new product of the subarray if you um, increment AI, like A1. And for any general AI, it will become this, that the new product will become prod plus sum minus AI. How did we come up to this equation? You can just try to do some dry run or just understand that uh, like if you say A1 equal to or any element AI, or maybe let's take A0 for example here. A0 equal to A0 plus 1. So the product which was initially equal to um, this thing, now it will become this A2 and so on till A of n minus 1. Basically, it got incremented, which can be called as A0 into A1 into A2 and so on, plus A1 into just distributing it with A0 and with just 1 here. So this is the total increment. And
we want to find the maximum product rate, so we will just
sorry,
increment the
sorry, sorry,
element this minimum.
sorry.
Hello.
I think that I made some mistake here, but the key idea is that the smaller the value of AI, the better it is. What did you say, by the way?
Just increment the minimum element of a array by one
Yeah,
and multiply all the elements.
yeah, that's what we will do. I was just showing a little bit of the proof. Yeah, I actually didn't go for the proper proof. I was just trying to give the intuition here that the smaller the value of AI, the smaller it is, the maximum new product, this new product you will have for a smaller value. So we will just find the minimum value in the array and increment this one. After that, we will have the maximum new product. So does this make sense? Just write yes or no inside the chat. Like, shall we move on? Okay, great. So for its code, what I did was to first of all take the inputs. Then instead of uh, like running a for loop for finding the minimum, I was a little lazy doing the contest. Wanted to write the code faster. So I just sorted the array and incremented the first value, which is going to be the minimum. Then I said that just find the product of this array now and printed this. And by the way, guys, for those who don't know about it, you can just ignore these lines. Um, you can ignore these lines and these lines. And all the other part is just these debug lines also, debug and CR and DL. So just ignore these lines. For every test case, we are writing the code here. And this code is for just running up multiple test cases. Yeah, so let's see the third problem. The third problem says that there is So the third problem says that like there is something like a matrix or a rectangle or actually a square, 10 by 10 square, 10 plus 10 square, where if there is like crosshair, the point system is something like this. For the outer ring, the points are just one. For the second ring or the level, the points will be two. Then for the next level, the points will be three. And for this level, like they have actually shown this good diagram that for the outermost ring, the points are just one. For this ring, I hope you are able to see my cursor. The points will be two, 2 points each for these cells. Then for these cells, the points are three. For these cells, the points are four, and for these are five. Just confirm it once whether the problem is clear or not. Is there anybody who is not clear with the problem? Like this part, how the points are being distributed? Okay, that's good. And we have been told that we will be given a 10 cross 10 matrix where this X signifies that there has like you just have to add up the counts. Obviously they have made some story, but the point is that you just have to find the sum of all the points for these squares. Here again, like this is pretty standard also. You just see wherever you have points like these, you can even remember this thing so that you don't spend time for thinking about it whenever you get a problem like this. That if there is a problem like this where the problems towards the center are having more points, just find out its difference from the top, left, right, and down. And the points will be equal to the minimum of, if it is zero based indexing, in that case, the minimum will like the minimum of I, if the coordinates are I comma j, then I plus 1, n minus I, j plus 1, and m minus j. You can try to figure it out. Like for the first row where I is 0, the count is 1. For I equal to 1, the count is 2, and so on. So I plus 1, similarly for j plus 1. And for the last row where I is equal to n minus 1, the count is, the points are 1. So that's how we got the relation of n minus I. I'm going a little fast because this is something you should be able to do, or I think that most of you have already done this. And once you find out this, you will get the number of points you will be getting for any I comma j coordinate. And now you just need to find the sum of all the um, x marks. So I did it just by like this, that I created a function in which I will be passing the row and column, and it will tell me how many points does that coordinate have, where I've calculated up, down, left, right, like just some generic stuff which can be used at a lot of places. And then I have this for loop. Since we didn't really have to do anything with the inputs, like I didn't really need to store it inside any matrix, so I just took the inputs and used them in the way I wanted. That if it is an x, then get the score of that point and add it to your answer, and at the end just print the answer. So does it make sense? Shall we move on, or does anybody have any query regarding this problem? Just write yes or no inside the chat. That shall we move on or re-explain? Okay, that's cool. Now for the D problem. So it says that you are being given a strip of paper S that is n cells long. Each cell is either black or white. In one operation, you can take any k consecutive cells and make them all white. Find the minimum number of operations to remove all the black cells. So it just says that you are gonna be given a string where it will be of length n, and it can have either a black or a white, black or a black, like anything, either a black or a white. So we have to find, and we have been given an integer k also. This k is the length of the subarray. Like you can just choose any subarray and make all the, sorry, any substring and make all the characters there as white, all the cells there as white. And we have to tell the minimum number of operations, like this is being considered as one operation. We have to find the minimum number of operations to convert this given string into a string of all w's, like all whites. So like just by reading this, one thing which should be coming to your mind is, what if I have something like this where k is 3? Will I ever have a string like this? Will I ever have a string like this where the first character is black? It doesn't make any sense. Like it doesn't make any sense to start from a black character unless I don't have any choice. But the main idea is that whenever I apply an operation, I will try to have a W as the endpoint. so that I can cover up most of the cells. For this cell, I must have at least one subarray covering it, and I don't want to have uh, a subarray covering up some unnecessary material. Like you see that if I start my operation from this point, it doesn't have any benefit for me since it is already. Sorry, I have to make white. Okay, I wrote it wrong. If there is something like white, black, 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 yeah, in this case, so it doesn't make any sense to choose this subarray. I will choose this subarray only. I will always start on with a subarray which is having the first element as a black. Does it make sense? Just tell me yes or no. Uh, does it make sense to you that I will always start on with a black element and never with a white one? Unless I don't have any other choice. Maybe if there is something like uh, white, black, and k equal to 2. So obviously here I don't have any other choice. I don't have a choice to start with black. I have to start with this point only. But in any other case, if I can start from this point instead of this point, then I will always start on with this point. Just write yes. or no. That does it make sense to you? This is this is the intuition. So what we will do is just traverse the string. If this is my string, I will just start traversing it. And as soon as I find a black cell, I will say that, hey, I will apply my operation here. So for the next key elements, I don't care whether they are black or white because they will become white. So I will just say that, hey, now start searching from this point onwards and skip this part. That's it. This as simple as this. If you want the intuition, then this should look very obvious. And for the code part, I just like, did the same thing. Took the inputs, took the string as input. The answer variable I created is an integer because I know it can never exceed n, and it is an integer, so it will definitely be an integer. Then I just run up a for loop from 0 to n and said that whenever I find a black cell, I will apply an operation here, which means that for the next k minus 1 elements, I don't need to worry about them. They will definitely become white and I can skip them. I went from left to right and then right to left and printed them again. No, no, no. You don't need to check from right to left or left to right. Just one of them is left. Someone is having his mic on. Please mute yourself. Just please mute yourself, Ayush. Yeah. So, shall we move on to the next problem? They asked for the minimum. The point behind telling the intuition was just this thing that you will always get your minimum. Like you don't have any other better choice. You don't have any better choice than starting at this element. You see that you have to, if there is a black here, you have to cover it in some subarray. If you're starting on from this point only, then you're not having any disadvantage. Like you're not losing any potential which you could have by starting from here or by starting from here. You know, if there is a black at this point, starting at this point will cover it. If you start from here where we have a white cell, then you're just wasting your resources. Like you're just wasting up the thing, the size of your window for which you are able to make elements white. It will be just a waste of resources. And if you start at this point, let it be black or white, whatever, in that case, you will just miss up this element. So again, you will have to apply an operation. That's why we can conclude that if you start from this point, then you will always have the most optimal answer. Okay, okay. You are skipping the next three cells. Yeah, I'm skipping the next k minus 1 element cell. Yeah. Okay, so let's see the E problem. You love fish, that's why I don't know about the story. It's useless. So basically, the problem says that there will be some. I don't know what did they mention in the story, but it was something like you can think of them as buildings or maybe some stones or some levels, anything. And the key idea is that you have to say that for a height h, for a height h of this wall, like this thing to be h, and you will be given some water, let's say x here, like this thing will be given and this will be given. You have to choose some x such that if you fill up water till the height h, like here this is the height, so if you fill up the water till this height h, unless like all the remaining area, then it should not exceed x. Like the water you are requiring here should not exceed x. So if we say water rec, then it should be either less than or equal to x. It can never exceed x, and we want to have a like largest. You want to have the largest container or whatever word that they use in the problem, which is possible. I tried to brief out the problem. Obviously, you can read the story here, but what they are actually willing to see is that um, I think they use some word. You have a piece of coral. Yeah, so there is some coral. Anyways, just like this. Just understand that there are some blocks and you will be given some water. You have to find the largest value of h. Chetan, you can raise up this query for your wrong answer after the session, and some mentor will help you out. For this part, like you will be having some blocks and you have some capacity of water. You have to find the maximum value of h such that all the columns will have water level till x, like till w. You don't need to have water above it, like this block is empty. And the water you are using should not exceed the given water. That's all the condition is, and you have to find the largest height. So is the problem clear? Is the problem clear, guys? Okay, that's good. So what is the idea? So let's see the idea. For this problem itself, let's see this problem. What if I had chosen this height? My height was this. I would just require this water, like this much water. So you will just require this much water for this h. Let's say if the h is still here, then you will require this much water and this much water. So for a greater h, like you can just visualize this also. If h increases, then the water rate will also increase. The requirement of water will also increase. Now you just like if you are being given this h, can you find how much water you require? You definitely can find. You just need to say that just traverse over this array, and for every value which is like smaller than this h, just add up the difference of height. And if in case the tower is like this block is larger than height, just ignore it. So in this way, you can find the water requirement, and this water requirement should be less than or equal to x. And you have to find the largest h which satisfies this condition. Does it make sense? Like very straightforward stuff till now. That you just need to find out the largest h such that this condition is being taken care of. Like, this is satisfying. This condition should satisfy. Now you can notice here one more thing. Like as we said, that if height increases, then water rec will also increase. If height decreases, then water rec will also decrease. Can I say that apply a binary search on this H? Binary search on this H. Just apply a binary search here. Yes,
Yes.
can I say this?
Yes.
We can say this. How did we get the intuition? We got the intuition because we saw that if H increases, then the water rec is increasing. And at some point of time, when the water rec becomes larger than X, then we won't be able to have those, like, just imagine it in this way that there is some range of H. At some point of time, if you are getting true, which is that yes, you have this much water to fill, then it means that you can have lower height also. And if at any point you get a false that you don't have this much water, the water rec is larger than X, then for all the larger values of H, you will have false. You will just apply binary search to find the largest T here, like the largest H for which you are getting a true. Just this much. How will we do this? For finding water rec, we can just traverse over the array and find out how much water we require for this much height. Comparing it is just one liner thing. So we can create a predicate function which will return me a true or false, and I can apply binary search on it. Let's see the code. So for this, first of all, I took the input n and water. I think like you can take up and give any name. I gave the name water, and then I applied a binary search from start to end, where end is equal to 2e9. So the starting range is 0. Obviously, if you have height equal to 0, the water requirement is also going to be 0, and which will definitely be greater, less than or equal to water, which we have been given. Uh, in the problem statement, it was mentioned to be 1, I guess, the minimum. But like this much is enough to say that start is 0. For the end part, just imagine if the given water is 29, like you can read this in constraints, like the maximum water is 29. And what if there is just one column with height equal to 29 already? So in that case, you can have like 2e9 to be the maximum water level such which you can build. After that, if you try to have like 2e9 plus 1, you can try run for it. You will always get a false that you don't have enough water to have this high value of H. That's why the start and end are 2 was 0 and 2e9. Initially, I declared end equal to 0. Then
Hello.
there is a predicate function. Yes.
Can we start the start variable with 1?
Well, let's read it in problem. It's better. It's generally better to declare something for which you are 100% sure. है ना? So if you want to declare it with 1, you need to check it once. What if your value of x like x is just 1 and there are 2e9? Okay, so the minimum value of ai is 1. So yeah, h can be 1. You can start with 1 also. Yeah, you can start on with 1 also. Oh yeah, in the problem it has also been mentioned that h is greater than equal to 1. But in general stuff, we try to declare something which we are definitely 100% sure. So if you have any doubt about like 1, then don't declare it. Just declare something which you are 100% sure. Like this is some clean code which I was writing. Generally, I don't write this kind of code during contests, and I just declare it with something like 1e12, for which I don't even need to think about whether it is possible or not. I'm damn sure that it will definitely not affect my answer. So something like that. Then there is this binary search where we are finding the mid, checking if it is possible or not. If it is possible, then update the value of answer and increment the value of start. Otherwise, decrease end and at last print answer. And here is our predicate function with name is valid. which is taking the height as input, like this mid, which is the height as input, returning a bool. I think low equal to 1 will not work. No, Chetan, it will work. If you say low equal to 1 or start equal to 1, it should work because h will definitely be greater than or equal to 1, and it is also been mentioned in the problem as someone said. Anyways, let's come here. So here I saw that there could have been some overflow. That's why I gave it a long, and just found the total water I would require for having height till here. And at last said that it should be less than equal to water. If it is the case, then it's good. Otherwise, I will return a false. So I hope that this problem is clear to you, and you can learn about binary search in case if you don't know about it till now. And for the template stuff, you can see this, that after taking inputs, I just had to say something like this: starting range, ending range, and declared answer as something for which I was definitely sure that this will be the case. Then there's some predicate function. I'm not writing all this stuff here. Then I have this something like a template, which will almost always be the same. Finding the mid, saying bool equal to check, like saying bool check equal to is valid. I always say the same thing. Here, just saying that if it is the case, since I have to find the largest value of answer, so incrementing, like enlarging the value of start and saying answer equal to mid here. In the other case, just say end equal to mid minus 1. This will always, like whenever I have to find the largest values which satisfies the condition, this is always the same thing. And here, this is the predicate function. I created it as a lambda function so that I don't have to pass on this array, water, everything. It's generally convenient. Okay, so let's move on to the next problem. F. So this problem says, can height be 118? No, it will never be greater than 2e9. But yeah, you can give it a larger value, though 118 is not being recommended. Otherwise, you will have to see for the you will have to see for the overflows properly. But for something like 112, you can just chill out if you are using long. Show the code once more. Okay. I can show the code once more. By the way, it would be available to you in the description of the YouTube video. You will be given all the links. Change it to smaller value ACC. So for anybody who was willing to read. Okay, that's great. Yeah. So for this problem, it is something like this. It will be given an array A. You will be given an array H. What it says is that you can just choose up any subarray from like any subarray. Basically, this is for some trees. There are some trees, पेड़ पौधे, and for every tree there are two things. Like AI will tell you the number of fruits or the points, whatever it is, for the ith tree, and HI will tell you the height of the ith tree. And we are being told that we can choose up any subarray such that for all the I in the range from L to I is less than R, HI should be divisible by H of I plus 1. This should hold. This condition should hold. This is what we have been mentioned in the problem. So can I say that HI mod HI sorry this HI plus 1 should be equal to 0? Can I say this?
Yes.
We can say this for any H, like for any I, where HI mod HI plus 1 is not equal to 0. Let's say I have a substring. This is my subarray. Sorry, this is my whole array. This one. And this is my subarray which I have chosen till now. Here it has some sum, the sum of all the AI. Sum. Oh yeah, but one more thing. like in the problem, it said that this sum should be less than or equal to a given value. Let's say the given value is x. So it should be less than equal to x. It should not exceed x. And the subarray should have this condition as been told above about h divisible by h I plus 1. And we have to find the longest subarray, length which satisfies this condition and this condition. So for this, one very obvious thing which I can say is that in the array, if there is a case like this, that this hi and this hi plus 1 doesn't follow the condition as being told above, then they cannot come in the final subarray. Like none of them can come together in any of the subarrays. Like if I call the above subarrays as valid subarray, if I define a variable like valid subarray, like you don't need to define it while coding, but here I'm doing it just to make it easy for you guys, like for explanation purpose. It should follow hi mod hi plus 1 equal to 0, and the sum should be less than equal to x. So any subarray containing both these elements cannot be a valid subarray, right? And if there is a subarray whose sum is greater than x, then it is not a valid subarray. But if I remove an element from the beginning or the end, let's say I remove an element from the beginning, then this new subarray might have some less than equal to x or might have some greater than equal to x. It won't become worse. If the sum was initially 5, it will become maybe like 13, 12, 11, something less, something smaller than what it was earlier, since all the values are positive. So I can apply something like a sliding window here. Now the part of how did I get the intuition? This is the thought process I had during the contest after reading the problem, that uh, if I have a window from start to end, like I'm defining the ending points as start and end, and I want to add this new end to the subarray, then the height of new end must be greater, sorry, it must divide this part. This must hold. If it doesn't hold, then I can say that, hey, the new subarray will not be able to have all these elements. It won't have them. Other thing, let's say I added it and the sum became greater than 0. It means that I cannot have it as a valid subarray, but I can pop out some elements from the beginning to decrease the sum. And as soon as the sum becomes less than equal to x, it's fine. And I will just
Here
store.
it should be, hello?
Yeah.
Here it should be sum greater than x. Right?
No, like I'm saying that if sum is greater than x, then I will pop. But as soon as I get that my sum becomes less than equal to x, then I will stop at that point of time. Let's say
Okay.
if sum was 15 and I remove the element 2, then I got a sum 13. Like it will obviously reduce since I am removing positive elements, and at some point of time this sum might become less than equal to x. At that point I will stop and find the length. The length will be simply end minus start plus 1, and I will say that answer equal to the max of length and answer and length. So as simple as that. So this is nothing but a sliding window problem. Like after this, I just felt it in this way, that for every ending point, I will just check what is the starting point and what can be the longest subarray. which ends at this point. So ending at this point, or maybe ending at this point, ending at this point. What is the largest length of the subarray I can have? This was the thought process, and it depends upon your practice how intuitive you feel this. But the approach is this, and you might require to spend some more time in case if you are not very familiar with this. Now, for the part of how to implement it, I can say something like this. I have this array. For finding the longest subarray ending at this point, initially I will say that, hey, my starting point is just 0. And I will keep incrementing my ending point from 0 to n minus 1. One by one, I will increment it. I will just check that if h of end minus 1 mod h of end, it means like if this is the end, then the last element for all where end is greater than 0. For all of these things, if it is not equal to 0, then just say that, hey, starting point should be equal to n now. Just remove up all the elements of the previous subarray and reset the sum. This thing. Basically, just shrink the sliding window to the maximum and point you're starting here. Otherwise, just increment the a of n and then shrink it, like just shrink it till the sum is greater than x. So till it is greater than x, just keep shrinking it, and at the end just say that, hey, len equal to n minus start plus 1 and answer equal to maximum of this, the maximum of start n. This is what we have to do, and the code looks like this. So the code says that, first of all, taking the inputs, here also taking the inputs, declaring a answer variable, a sum variable. Sum can exceed the integer range, so that's why I've created it as a long long, and then a starting pointer. This is nothing but a sliding window thing that if like this is an extra condition which generally we don't have, but for this problem we have that if this element is not dividing the previous element, then we cannot have both elements in the same sliding in the same window. So just shrink it till this point, sum equal to 0, start equal to 1. Then add this element to the window, shrink it till the sum is greater than k. So instead of x, we have named it as k here. And then find the length, update the answer, print the answer. As simple as that. You cannot write CERR lines during the code. Like if you write CERR stuff, it won't affect your answer, but it will take time for printing it. It won't print it in the standard output, but it will print it. So it will just give you a TLE. Always use the DBG statements. We will see DBG statements in the last problem. Yeah, for the shrinking part, we have been just saying that while start is less than equal to n, which means that the window size is having at least one element, and the sum is greater than k. So we must remove some element. We will just remove the first element. So just uh, subtract the sum which we had added at the point, like at the time of adding it to the window, and then start plus plus for updating the new start element. That's how we have been shrinking it. Okay, so does it make sense? And should we move on to the next problem? And just one more thing. Did you feel it intuitive with the things I said in the way? Like, did you feel that if you had noticed those parts, then you should be able to think about the approach for this kind of problems? Yes or no? Shall we move on? And for the people who have been watching this video on YouTube, please make sure to fill the feedback form and give your valuable suggestions, even if the suggestions are basically criticize. Like, feel free to criticize also, the suggestions you give, we take them into account and improve. I use prefixum here. You can use prefixum array also, but it's not required. So let's move on to the next problem. The next problem, in a nutshell, says that you will be given some A, B, like a string of containing of A or B, either A or B. And in one operation, what you can do is just change this AB to BC, and you will get one gold coin or one coin, whatever it is. You can take up BA and change it to CB, and again you will get a one gold coin. This is what the problem says, and you will be given some string of A or B, like A B A B B B A B, something like this. Any string containing only A or B. You have to find the maximum number of gold coins you can collect by making like these operations. You can make these operations any number of times you want. Obviously, whenever you get a C, you won't be able to make any operations anymore. So yeah, the problem was good enough. Like, it was an observation problem, not too hard. It was pretty simple, but for many people, I think it might have been not that obvious. But you had to observe was something like this. Let's say if I have a B and A here, just pick up any string like BAA, any number of A's you have, it doesn't matter. What you can do is just take these two elements, CB, then take these two elements. You will have CCBAA, whatever you have. Then take these two, then take these two, and then take the last two. So all the A's you have, the number of A's you have, you will be able to get that many gold coins. Right? If you have a B and some A's, you can always get that many gold coins. Right? Just say yes or no.
Yes.
It was an intuition. Like, not an intuition, but an observation. Now the part is, if there is something like AA, B, A, B, how many gold coins do you think we can obtain? Just try to have a, like, I'm giving you 20 seconds. Just try to think about it. How many gold coins you can have?
5.
5.
Yes, we can have 5 gold coins. I can have these elements as a pair and these elements as a pair. We are able to visualize them as pairs now. That just one B can have many A's and convert all of them. What if it was something like this? How many B, like how many gold coins now?
3.
Yes, 3. Because I can have this as a pair. Once I apply an operation here, it will become CB. So, like, I cannot have this as a pair. Like, I will not be able to convert these into gold coins. I can choose only one side. This was the next thing which I observed. Then I thought about what if a case is like this. Here I can have this as a pair and this as a pair. So the problem, like my problem just turned into find, like turn this stuff into something like 2 comma 3, an array of 2 comma 3, where I'm counting these elements and these elements, just counting out these elements. Obviously you don't need to store it inside an array, but storing it inside an array was not really going to give you a TLE. It was not going to affect your time complexities by a large amount, so you can even take them. Basically, the thing is just find out all the chunks of A's. If I'm saying that there is a chunk of 2 A's here and 3 A's here, it definitely means that there was at least one B in between. So if the array size is A dot size, which is, let's say B, like let's say M, that there are M chunks here, you will at least have M minus 1 B's. Right? Just try to think about it. if you're just storing all the count of occurrences of these elements inside an array, then m minus 1 B's will at least be there. So there will be at most one chunk of these A or one group of these A which will be missed, which you cannot turn into goal points. Obviously, we'll just take up the minimum size window or the chunk of A's. Let's say if there was something like AA, D, A, B, A. So you will just convert it to 2, 3, 1 and just remove the smallest one there. And just remove the smallest guy. So can I say that if sum is the number of A's I have and Mn is the smallest window I have for A's, for the smallest window I have for A's, then I will just say that sum minus Mn is my answer, right? Right. Does it feel
What is
intuitive?
hello?
Yeah.
What is sum over here?
This sum is the number of A's here. You can call it as CNT, count, whatever name. I give it a name sum, but you can give it any name. Like sum is the count of A's I have, like the A here. Here you see that A has been occurring 6 times. So sum will be equal to 6. Or you can think of it as the sum of the elements of this array. Right. So after this point, one thing which you might say is that, hey, here I said that I can make up these two pairs, so the answer should be 5. But um, according to my approach, I'm getting this vector there of 2 and 3. So answer should have been 5 minus 2 equal to 3. And this might come to your mind that the logic is incorrect. So yeah, we have to say one more thing. We can say one more thing, that just assume there was one chunk of size 0 here. Whenever you get two B's together, just assume that there is a chunk of 0 A's in between. So the minimum guy will be 0 and you will be just removing 0. Like I'm just trying to right now, I'm just trying to tell you about the intuition I had, the way I was thinking about the problem. If you don't feel very comfortable with it, then just 1 second. Yeah, then you can have some different way also.
Okay, so we store the minimum difference between the all B's.
Yeah, you can say this also. So now the problem can be said as, just imagine there is a B at the start, then some A's, then a B, like then some B's, some A's, B, A, and at the end you just put up B. You don't really care whether it already existed there or not. Just put up a B there. Now, just try to find out the differences between B's. So what you're going to do is just store the indices of these B's and find the minimum difference and consider one B at -1 index and one at an index, and all the others at the original indices there are, and the minimum difference between two B's will be our answer. So this is a very simple approach for this answer. Obviously,
Hello?
not obvious, but during the contest, I actually got some other intuition. Like this above intuition was simple, like this thing only. But here for finding the difference, what I did was to uh, brute force it. Not brute force it, but made it a little complicated. That counting out how many A's there are, then how many A's there are, how many A's there are, and counting how many B's there have been coming. So
In problem tag, DP is sorry.
no, DP is not required. Like you just need to find the occurrences indices of B and then find the minimum difference between any two consecutive indices. That will be your answer. And for my approach, what I did was to just find this size, this size, this size. But in my approach, I was not able to find this. Like I was missing this part. Or what if B is coming at the end, or what if B is coming at the start? So for that, I just counted the occurrences of B also, stored it inside a variable 0. And then at the end just said that, hey, if 0 is greater than equal to uh, this M, this A dot size, which is M, then in that case, Mn equal to 0. I said it to be something like this. So a quick overview of the problem, what we said was that here we have some A's, some B's. We notice that you can have some A's and a B to club up together and get uh, get some coins. The count of coins is equal to the number of A's you have. Now we wanted to decide like whether to have this B with this these A's or with this one. This was the confusing part. So for that we got some intuition that hey, just make an array something like this, which tells you how many A's have been coming together. And if the count of B's is equal to M minus 1, like there will be at least this many B's. If there are these many B's, in that case, you will be missing out having something like sum minus Mn as your answer, where Mn is the minimum element of this array and sum is the sum of this array. But what if there are M number of B's? So for every component, you can have one B. Like here you see that you have three B's and three components. So you can club them together like this. In that case, you can just say Mn equal to 0. And I think that if I explain more for this approach, it will be something like spoon feeding. So I think that this much explanation should be enough. After that, you must put up more efforts if you are still not able to understand. Does anybody have any specific query for this problem? Or like, please tell me if it is clear or not. Just yes or no. Okay, that's great. So let's move on to the coding part. For the code, first of all, I took the inputs. Then I declared this A array in which I will be storing the size of the window which has only A's. Though it's not required, you don't really need to store this. You can skip, like you don't need to maintain a vector. Then this 0, keeping the count of the number of B's I have got till now. This sum count, covering like can I get someone from the problem names? G. Like I read the problem name, I thought that it might give me some intuition, but it didn't give me any intuition. And then I got like I just read the problem again and I saw this observation. So the problem named in LP. This MN and the sum have already been told. Now having a window starting from like 0 till L. If it is a B, if the current element is a B, then just increment the count and continue. Otherwise, just find out how many B's there are and increment that count, like push that count into the array and increment the count into the sum and consider like have the minimum element in MN and update the value of start. After that, we say that hey, if the number of 0, like if the number of B's is greater than or equal to A dot size, it means that I have enough B's for every chunk of A's. So I can just I don't need to subtract anything. That's why I've been saying M equal to 0. Obviously, you can just print up some and return from here. Like you can say if this is the condition, then just print some. Otherwise, print some minus M. Instead of that, I just set it to be M equal to 0 and then print it. So this is one way, and the other way, as we discussed earlier, that just find out the indices of all the elements and find the minimum absolute difference. So I think that we should move on to the next problem now. This is used to inside the chat. Okay, so let's move on. The last problem, and this was quite fun. This problem says that like there are some buildings. There are some buildings where some buildings will be connected to each other. This is a bidirectional road. Bidirectional, so you can move on from any building. Like from this one, you can go in both ways. So this is bidirectional, and in this way, some of them will be connected. In the problem, we will be having one node represented by A and one node represented by B. What it says is that there's some guy on the node A which is trying to catch the guy on the node B. This guy will try to catch him, and the guy B will try to escape, will try to run away from A. Both of them will go in the optimal manner. Let's say that B knows about where the guy A is going to move next. So we have to tell, is it possible that this guy B can always run away from A? B can run away from A and never be caught. So we have to tell something like this. And as in this example, A can move on to this node. So for B, it has two choices: either remain on the same node or go here. So B cannot escape. A will come here, and B will, if B just stays at the original place, then on the next move it will be caught. You know, and I think that he has to move somewhere and everywhere. Still the same again. Yeah, so you can do something like this. Now you have to make some cases here. In this problem, you had to make some cases. One of the observations, like one of the things which has already been mentioned, is that all these buildings will be connected to each other directly or indirectly, which means that there will be just one component. If there is just one component, and one more thing, there will be n lines, n edges. You can understand this as a graph. It can be understood as a graph where nodes are buildings and the edges are the roads, and we have to like we are already being told that there is just one component and there are n nodes, n edges. This much information, like these three things, are enough to conclude that there will be exactly one cycle, like no more than one, no less than one, exactly one cycle. So how is this so? I think that this is a good exercise for those who don't know about this, and for those who know about this, it's already good enough. This is something pretty standard. You should know about it. And just to give you some idea, I will say that you can form a tree in n-1 edges, where all of the edges will be like all of the nodes will be connected to each other directly or indirectly. Then for the next node, wherever you end it, like wherever you connect it, you will get a cycle. You will get a cycle with the nth node, and you have to place it somewhere. So you will definitely have a cycle. it is also being mentioned that between any two nodes, there will be just one edge if there is, like at most one edge between any two nodes. So there won't be a case where there are two edges like this and there is no cycle. No, it won't happen. So this much information is enough to conclude that there is just one cycle. There is exactly one cycle. Now the cases you could have concluded was something like there is a cycle in which A is there and B is in a branch. Like for a graph, if there is some cycle, exactly one cycle, there it will have exactly one cycle and it can have some branches also. The branches can be trees in themselves. So like this is also something you are expected to understand on your own. Now for the cases you could have built was that A is inside the cycle and B is outside. So A is trying to catch B. If B could enter the cycle before A come to this point, then A can, like B can just run away from A and A will never be able to catch him. Pretty obvious. But if A and B are both in the inside the cycle, it doesn't matter how many branches there are because A will just keep running towards B and B can just run away. A will never be able to catch B. What if B is inside a cycle and A is outside? So B can always run away from A. B is inside the cycle before A, and this is even better for B than this case. So again, B can run away. If A and B are in this way, that B is at a place like this and A is at a place like this, so A can just run towards B and B don't have any place to hide because like the only way B could have been running away from A for indefinite time was by looping inside the cycle, running A away from A inside the cycle. Now, since it cannot reach the cycle, it will be caught. So in this case, we will have a no. In this case, we will have a yes, and in this case, we will have a yes. For this case, it depends on whether A will reach to this point first or B will reach to this point first. If A and B are equal, then also it is no. Like A has already caught B. For a case something like there's a cycle and B is closer to the cycle than A, then again the answer will be yes, since B will reach to the cycle first and can just keep running away from A. And yep, again A will not be able to catch B. There could have been a case like there is a cycle like A belongs to another branch, B belongs to other branch. So as soon as B, like you see that every time we will have the focus on the node where B has to reach. Once B reaches inside the cycle and A is not at the exact same place, like if A is even one step further, it will never be able to reach. Like it will never be able to catch B. So from this much we can just simply say one thing, find out the cycle, like one very simple solution. Obviously there can be better or even more optimal solutions. This is my solution which passed all the test cases and I thought it to be quite intuitive, that find the cycle, just find out all the nodes of the cycle inside the graph, whatever graph you have, find distance of all nodes from A. Now just repeat the same thing for B. So now you know the distance of all nodes from A for all nodes from B. Now find the closest node which is inside cycle, like closest node to B. So closest node to B in the cycle. Now, once you find that node, you just need to say that, hey, if dist of like dist from B, let's say dist B to be the distance of node from B, if dist B of that min node or like whatever that node was is less than dist A node, in that case, we will be able to reach to the cycle first, like that node first, without getting caught by A. And then you can have the answer yes. Otherwise, answer is no. Otherwise, no. So, does this make sense? Does it seem intuitive that um, we went very step like for this problem especially we went step by step, that once you saw this part you realize that hey, graphs can be used since you're having um some buildings connected with each other through some roads. This is already pretty intuitive that hey, maybe we have something like graph and edges. Then it was already being mentioned in the problem that it is having just one component. It was also being mentioned that there are n nodes and n edges, like n nodes and edges. So it should directly come up to your mind that it can have only one cycle now. Remember that it is true because we have one component. If there could have been multiple components, then we could have multiple um, cycles, like one cycle per component. For every component, we will have at most one cycle. Right. Now, you can say that, hey, yeah, this much is enough. We saw that we have exactly one cycle. We try to figure out a little bit that what can be the cases. Maybe A and B are both inside the cycle. In that case, B can always run away from A. B is able to reach to the cycle before A catches him. So again, this will turn out to be something like this case that now B can just run away from A forever. B is inside the cycle already and A is not in the cycle. So while A comes for like A comes into the cycle, again the same case will happen. So again, like B can always run away. A and B are both inside some branch of the cycle, like of the graph, not in the cycle. So if A is closer to the cycle, then B can never reach to the cycle, and if B cannot reach to the cycle, then B will be caught. If B is closer, then B will reach to the cycle, and again it will be something like this case where B can run forever. And what if A and B are both on different branches? So the node which is closest to B, we just want to find which one will be able to reach to this point first. If A reaches to this point, then it will become a case like this one, where B is in a branch and doesn't have anywhere to run. Otherwise, it will become a case like this, or maybe like this, where B is inside the cycle and can run forever. So in these cases, we will just have yes. And what if A and B are both equal? In that case, we will have no. In that case, we will have no because uh, we don't need to check anything. We can just directly say that, hey, he will have caught him. For this procedure, we had very intuitive stuff, very simple stuff, like not maybe not very optimal, but simple to think that just find out the cycle, all the elements in the cycle, find out the distances of A and B. Our motive is to find which one will be able to reach to the closest cycle node from B. And then we found it by running a for loop for B. And after that, we just compared the distances uh, till this node from A and B. If B can reach first, then the answer is yes, otherwise no. So this is covering this case, this case, this case. Like for the case when B is already inside the cycle, then the distance will be 0. So 0 is always going to be less than the distance from A to B unless A and B are equal. And if A and B are equal, even then this condition will be there. But we can handle A and B to we can handle it through just like in a base case or a corner case. And for all the other cases, like whenever B enters first, this is going to hold, and that's how we can get to the answer. Okay, so some of you have written that you have got the solution, like you have understood the approach. Let's move on to the code then. My code is pretty long, like it's not short. I think that it can be made short, a little shorter, but anyways, it did pass all the cases. First of all, taking inputs, taking all the edges and storing it inside an adjacency list. This is the corner case, but if A and B are equal, just print no. Creating a visited node, like visited array and the cycle array, just for finding the nodes like in the cycle. So I actually use these two functions for finding all the nodes inside the cycle. Obviously, there are some different ways also. You can go with any of them. I went up with this way that since I was sure that there is just one edge, so I thought that let's try something new. And I just ran up of DFS, and like you can have any way of implementing it. It's not necessary to do it in the same way as I did. And after that, I did declare a BFS function for the purpose of finding the distance to every node from the node which I will pass inside this BFS function, and it will return me like uh, all the distances. So I just stored it inside arrays dist and distv. And here's the DFS calls, like the calling the DFS function and the get cycle function. After that, there is this lambda function. It's not necessary to use, but it makes our job a little convenient. That's why I was using it. The main idea here is that for all the nodes which belong to the cycle, just find out the minimum distance, like just find out its distance from B, and if it is smaller than its distance which you have already found, then update the distance and update the node, then find the distance of that node from A, and you can ignore these dbg functions, like these dbgs are just for debugging purpose. After that, you can just check if there's a cycle, like declare it. I declared it inside a variable. You don't need to declare it inside variable. You can directly write it here that whether min b is less than min a or not, and then you can just say that hey, print yes or no on the basis of this part. And that's how I wrote the code. I think it's pretty intuitive in this way. That's why I wrote it in this way. But yeah, there can be more optimal ways, maybe. I'm not sure about this though. The complexity should be the same, even in more optimal ways. So for those who have been watching it on YouTube, please give your valuable feedbacks. You will find the feedback form in the comment section at the top in the pinned comment. And whether you have a good experience or a bad, just write it up your suggestions and how you felt for the PCD, so that if even if there are some bad feedbacks, we can improve from them. That's why suggesting you to give even bad feedbacks. And you can find my codes inside the description. Inside the video description, there will be all codes, all the links to my submissions. And if you have any doubts, you can, for the members of TLE, you can just raise up queries and ask them in the Discord server itself. And for those who are just watching it on YouTube, then you can write it inside the comment section if it's not related to debugging. If it is related to debugging, then you can refer to someone's code which is similar and debug it yourself, or maybe write it. But I don't think that anybody would debug a 100-line code, 100-line long code. And feel free to ask anything inside the comment section. And thank you for watching the video. Bye bye.